I'm Anil Kumar, and in this video we are going to analyze a linear system and figure out how many solutions does each linear system have. The question is, how many solutions are there to the following linear systems? The first one is y equals to 2x minus 1 and y equals to 1 minus 2x. The second set of equations is 6x plus 2y equals to 5 and y equals to minus 3x plus 5. Third one is 4x minus 2y equals to 6 and y equals to 2x minus 3. So let's start with the very first one. Here I have given equations in slope and intercept form. The idea is you can straight away read the slope and the y-intercept and then decide how many solutions will there be for the given linear system. So y equals to 2x plus 1. In this case, slope is equals to 2 and the y-intercept, let me write b as minus 1, right? Now let me call them as m1 and b1 since this is for line 1. Let me do for line 2 also. What is the slope here? Y equals to 1 minus 2x, right? You should actually first see the equation properly. It is minus 2x plus 1, correct? Let's rearrange. Write in this fashion, right? Now I'll write on the slope. Now here the slope is minus 2 and y-intercept is number 1, right? Now what can you conclude from the given slope and y-intercept? Since we have different slopes, that means one solution, right? So the system will have one solution only. We don't have to really find the solution. Number of solutions is required, one solution, and the reason is because slopes are not same, right? So we have different slopes. Correct? We found that the two slopes are not the same. Now let's analyze the second set of equations and then figure out how many solutions do we have. Now this equation is 6x plus 2y equals to 5. It is a good practice to write it in slope and intercept form and then read the slope. Let's do it. So we have 2y equals to minus 6x plus 5. Dividing by 2, we get y equals to minus 3x plus 5 by 2, right? So for this equation, we have slope m as minus 3 and y-intercept is 5 divided by 2, correct? Let's do it for the second line. For the second line, slope is minus 3. We have slope equals to minus 3 and the y-intercept is 5. Now if you compare the slopes, that is for the first line it is minus 3, for the second line also it is minus 3, but the y-intercepts are different, correct? So what we have here is same slope but different y-intercept. And therefore, what do you conclude? Lines are parallel, correct? And therefore the number of solutions in this case will be none. So no solution. I could write none, right? Or zero solution, right? So there is no solution, none. Okay? So we do not have no solution since the lines are parallel, correct? Let's analyze the next set of equations. Now here we are given 4x minus 2y equals 6. Let's rearrange. We get 2y, taking this on the other side, equals to 4x minus 6. Dividing by 2, y equals to 2x minus 3. The other equation is y equals to 2x minus 3, right? They are same lines. They have same slope and same y-intercept, right? So they are coincident lines. We have in this particular case coincident lines, right? They overlap and therefore they have infinite number of solutions, right? I hope with this the concept is clear that if the two lines are not parallel or coincident, then they will have just one solution, as it is in this case, right? So in this case we have one line like this, the other line like this, so they will intersect at one point. So if the slopes are not same, then one point of intersection. If the slopes are same, then there could be two conditions. You have to check for y-intercept, right? If y-intercept is different, in that case you have parallel lines. Parallel lines means no solution, right? Well, the slope is negative. This is just a description, not sketched for the line. The other case is when you have two lines, but the two lines are exactly same. That means they are overlapping. If the lines are overlapping, they intersect at each point, right? So that is how you have to see the situation, right? So these are coincident lines, these are parallel lines, and these lines are not parallel. So that is how we have to analyze a linear system. I hope that's absolutely clear. Thank you and all the best.